So we will continue our discussion on the half wave rectifier. So in the last lecture actually we were discussing about the theory of the half wave rectifier. Today we will do a problem. Okay, so you can see here there is an half wave rectifier which is having an input voltage which is nothing but 120 volt Vrms, and the turns ratio of the transformer is given as 20:2, and you have an half wave rectifier, and there is a load resistance. Okay, there is a load resistance which is 100 ohm. So you have to find the following parameters. That means you have to find the Vp primary, Vp secondary, Vp out, IL max, and peak inverse voltage. So we will see how to do this problem. So first of all, I want to obtain the Vp primary. What is Vp primary? Vp primary is the maximum voltage actually, but it is given the RMS voltage at the primary is given. We can say the RMS voltage at the primary is given 120 volt Vrms. Okay, how to convert the RMS voltage into the maximum voltage? So if you take an AC sinusoidal wave, you can see the RMS voltage is somewhere here. So this is the maximum voltage and this is the RMS voltage. So how to obtain this? What is the relationship between these two? So Vrms is equal to Vp by square root of 2. Okay, so if you want to find the Vp, you have to multiply the RMS into square root of 2. You have to take the Vrms multiply with square root of 2. So this is the formula. So how to obtain this? So Vrms is equal to, that means at the primary, so we at the primary it is given. Okay, sorry, it is given. So you have to find Vp primary. Vp primary is equal to Vrms at the primary multiplied with square root of 2. That means 120 multiplied with square root of 2, it is 169.7. Okay, so this is the voltage, this is the Vp primary. Now what is Vp secondary? So now you can find easily Vp secondary. So Vp secondary is equal to Vp primary multiplied with 2 by 20. You can see the turns ratio is coming here. Okay, directly turns ratio. So this is nothing but 169.7 multiplied with 2 by 20, which is equal to 16.97 volt. Okay, you will get it. So Vp secondary. Now you have to find Vp out. Okay, so to find the Vp out in the half wave rectifier, I told you Vp out is equal to Vp secondary minus 0.7, and this 0.7 actually it is consumed by the diode. So it is 16 point, I think what is this, 16.97, sorry, 16.97 minus 0.7. So how much it will be? This is nothing but 16.27. Okay, so this much is the Vp secondary. That means 16.27 Vp out. Okay, next part of the question is to obtain the maximum current through the load resistance. So what is this current? That is the question. And you know the voltage Vp out at this, you know Vp out is the maximum voltage. So maximum current will be maximum voltage divided by RL. So IL maximum is nothing but Vp out is the maximum voltage across RL divided by RL, and this is nothing but 16.27 divided by RL is 100 ohms. That means you will get 0.1627 ampere. Okay, this much is the current, or you can say it is 162.7 milliampere, this much current. Then the last part is the peak inverse voltage. What do you mean by peak inverse voltage in a half wave rectifier? Okay, in a half wave rectifier the peak inverse voltage is nothing but Vp secondary, and you know that the Vp secondary we had already got it in the part B. It is nothing but 16.97. okay, so it is 16.97. so this is how to solve this problem. So this is one of the important problem you have to keep in your mind. Okay, so next we will discuss about the full wave rectifier. full wave rectifier, full wave rectifier. Okay, FWR usually. So we are talking about full wave rectifier. There are two types. One is the bridge rectifier. The second one is the bridge rectifier. The first one we are going to discuss is nothing but the full wave rectifier with sender tapped transformer. Okay, and the second one that we are going to discuss is the bridge rectifier. Okay, that's it. So first of all, the FWR with the sender tapped transformer. Okay, so that's all. That's what we are going to discuss. So full wave rectifier with the sender tapped transformer. So you are having a special transformer here. You can see this is the transformer. Okay, and this number of winding in the primary and the number of windings in the secondary. Okay, now there is a connection at the center. That's why it is known as sender tapped transformer. Okay, there is a connection at the center, and now you can see it is having two diodes, not one diode. Actually, it is a full wave rectifier. So I told you the output of the full wave rectifier will be like this. This is the output. Actually, it will contain full wave. Everything will be positive. Okay, you can also get negative also. It is also possible, but you can see here as the time progress, the output will be always positive, V out. Okay, that's it of the full wave rectifier, Now we have two diodes are required for this. Okay, two diodes are required for this, and these diodes are connected like this, and the load is connected here. Okay, this is RL. Now you can see you may give the V primary voltage here. So the maximum voltage appearing across this is nothing but this is the primary, VP primary. Okay, VP primary is the maximum voltage at the input. So what will be the output at this point? It is nothing but VP secondary. How to find VP secondary? VP secondary is equal to VP primary multiplied with, you have the turns ratio. I told you about the turns ratio, number of turns at the secondary divided by number of turns at the primary. So this, you have this equation. Now there is a connection at the center, I told you. So what will be the voltage between these 2 points? The voltage between these 2 points will be something different. It is nothing but the half of this maximum voltage. That means I am talking about the maximum voltage. So the maximum at this point is VP secondary, and this point is also VP secondary by 2. Sorry, it is VP secondary by 2 and VP secondary by 2, so that you will get a total of VP secondary between these 2 points. Now we have something like the polarity. Okay, what will be the polarity? So suppose if the input is positive, you will get here positive and negative. Okay, then you know that this will be positive and this will be negative, and this is ground, so it's 0 volt. Okay, so that means for this positive, this ground will act like a negative, and for this negative, this ground will act like a positive. That means ground is 0 volt. Now we will talk about the negative half cycle. So when we talk about the negative half cycle, during the negative half cycle, this is negative and this is positive. That means you will get a negative and a positive. That means it's ground itself 0 volt again. And when this is negative, I told you this is positive. That means you can get a negative. That means it will act like a positive and negative. That means it is nothing but 0. Okay, so ground point is 0 now. Okay, ground point is 0 volt. So this is also ground point. Okay, this is also the ground point. This is also the ground point. That means they are connected. So two grounds, if you are representing like this, two grounds, that means they are connected actually. That's the meaning. So I am not showing the physical connection here. It's connected already. It's understood. Now we will see what will be during the positive half cycle, what will be the current. So we will talk about the positive half cycle. During the positive half cycle, you see, during the positive half cycle, you can see here this is positive on the top and negative. That means during the positive half cycle you have positive here, that means this is positive, and you have a negative here, that means this is negative. So you can see the diode 1 is forward bias because positive is connected to the P of the diode, and the diode 2 is reverse bias. So this diode is off, and this diode, because of this, diode 1 will be on. So what will be the direction of the current? The current will be flowing through the diode 1, and it will be moving like this. Since this diode is diode 2 is off, it is open circuit. You can say it is open circuit. So the current will flow only through the load resistance in this direction. So when the current enters the load resistance, this end become positive and the another end become negative, and it is going to the ground, and that means that this ground and this ground both are same. That means they are connected, it is going to the ground. Now can you tell me what will be the voltage? That means you can take only the voltage between the ground point and the positive point. That means you have only the maximum voltage, it is Vp secondary by 2. So the input maximum to the diode actually through across the diode is only Vp secondary by 2. So the output maximum is nothing but Vp out is nothing but Vp secondary by 2 is the maximum input, and your diode will consume 0.7 volt. So minus 0.7, that will be the output. Okay, since the output is flowing like this, you see here, if you measure the voltage across this, you will get here a positive cycle. That's it, and you will get a positive cycle, and this voltage is nothing but Vp out, which is equal to Vp secondary by 2 minus 0.7. So I hope it is clear to you. Next part is, be very careful with this next part. You see here you have a negative because this is positive half cycle. Next we will see about the negative half cycle. This positive half cycle is finished. So in the negative half cycle, negative half cycle, what will be the polarity? I told you in the negative half cycle you are inputting a voltage negative. That means you have a negative at this end and you have a positive at this end. That means you have a negative here and you have a positive here. So you see here this negative is connected to the D1, this negative is connected to the D1 to the P side. That means this diode is reverse bias. That means this diode is off now. Then what will happen? You see here this is positive, in the lower side it is positive. That means your diode, this guy, this diode is having positive connected to the P. That means it is forward bias. That means this diode is on. So the diode D1 become off and D2 become on. That means you have a voltage between this ground, you have a voltage between the ground and the positive terminal, which is only Vp secondary by 2. It is connected across the diode. So the current will be flowing like this, the current will flow like this, the current will flow like this, and current cannot go up because the diode D1 is off. So current has to take the same direction as before. So you see here it is going down, it's going down. Since the current is going down, you can see it is positive and negative. So again you are getting the same kind of voltage at the output. Again you are getting positive. That means you are always getting positive, but the input was changing. This was your input. The input was positive and negative, but you are getting only positive at the output. So this is known as the full wave rectifier. That means you have an input which is you have an input which is positive, negative, positive, negative, this positive and negative, like this. Okay, this is your input, and your output is something like you have always positive. Why this positive? Because your D1 is on and D2 is off, I told you. Okay, because you have a D1 here on the top and D2 at the bottom. So D1 was on and D2 is off because D1 was forward bias. Now again in the negative half cycle, again you are getting the same voltage at the output. Why? Because your D2 is on now and D1 is off. Because of this phenomenon, you are always getting the same voltage. So again you will get positive. It's nothing but D1 on and D2 off. Okay, so that's it. So you can get it as the V output. And what is the maximum value of the output that you may get? It is nothing but the maximum input is only Vp secondary by 2, because you are taking the input across your terminal, which is ground here, and this voltage is only Vp secondary by 2. Okay, so your input is between the ground and the terminal. Let's say terminal 1, T1. Okay, let's say terminal 1, or maybe the input may be between terminal 2 and the ground. Okay, so the maximum you may get here is only Vp secondary by 2. So the maximum input from the secondary is nothing but only Vp secondary by 2. Okay, and Vp out is nothing but Vp secondary by 2 minus 0.7, because only one diode is on at a time. Okay, the other guy is off actually. So we will see we have the Vp secondary by 2 minus 0.7 as the output. Okay, now we will see in more detail. So we have got one equation. So we have I will derive the equations now. You have the full wave rectifier with two diodes, D1 and D2. Okay, and you have something like RL. Okay, this is your RL, and you will take your output like this, V out. Okay, this is your output. So you are giving V primary, which may be an RMS. Okay, sometimes I will give you peak also. So you can find P primary, and you can get here as Vp secondary, and I told you the voltage between these two are Vp secondary by 2, and this is also Vp secondary by 2, and only one diode will be on at a time. Suppose this is on, then this will be off. Okay, now we will see what is the maximum output, that means Vp out. So you have the output like this, positive and positive, V out, and this maximum point is Vp out. So Vp out is nothing but Vp secondary by 2 minus 0.7, and I told you there are n primary windings, turns ratio is n secondary. So n primary is to n secondary. So what you can say, how to find Vp secondary? Vp secondary is equal to Vp primary multiplied with n secondary divided by n primary. It's same equation like in the half wave rectifier. And how to obtain Vp primary? If RMS is given, V primary RMS. Suppose V primary RMS is given. Okay, then you have to multiply it with square root of 2. That's it. Okay, so these are all the basic equation which are related to the full wave rectification. Now how to find the current, maximum current? Suppose you have a maximum current through the load, the current will be always taking this direction. This is IL max. How to find this IL max? IL max is nothing but Vp out, that means maximum output. This is the maximum output voltage divided by the load resistance RL. This is how to find. Now we are going to discuss a very important thing, which is known as the peak inverse voltage. So peak inverse voltage, so you have something like this is your rectifier, this is known as the full wave rectifier. This terminal is grounded, okay, and this is D1 and this is D2. Now we will see, this is RL. Now we will see what is the peak inverse voltage. Peak inverse voltage, I told you we will consider the diode which is forward bias, not forward bias, reverse bias. Okay, now suppose you have an input which is a positive half cycle. So when it is positive half cycle, you can see the other one is negative. So during the positive half cycle, you have positive and negative. That means you have positive and negative here. The same thing will be repeated here. Okay, so this is at 0 volt. Okay, now we will see, you know that this maximum voltage is Vp secondary, and this voltage is Vp secondary by 2, and this diode is on now and this diode is off. Okay, so the current is flowing from this diode like this. So what will be the voltage at the output? I told you the maximum voltage at the output is Vp out, which is nothing but Vp secondary by 2 minus 0.7. That will be the voltage, because this diode which is on will take 0.7. Now the peak inverse voltage is nothing but the voltage across the diode. Let's say this is the voltage across the diode. You have to take these two voltages, and this is the voltage across the diode. Let's say this point, this voltage across the diode, let's say this is VA and this is VB. So the voltage across the diode which is off, that's what we are going to consider in the rectifier, is nothing but your peak inverse voltage. So what is the voltage across the D2? Voltage across the D2 is nothing but the voltage VA minus VB, because of this voltage actually it is in reverse bias and there is nothing here. Now we will see what is the voltage across, what is VA and what is VA here. So we will see what is VA. What is VA? VA is this point. That means this point is nothing but your Vp out, right? This point is nothing but your V out, or V out maximum is nothing but the V out maximum is nothing but Vp out. So VA has a maximum value Vp out. And what is VB? What is VB? VB is this point, and this point is nothing but your Vp secondary by 2, but you see this is negative, so Vb is minus of Vp secondary by 2 with respect to the ground. So whatever I am saying, all these voltages are with respect to the ground point. Okay, so when I talk about Va, it is the voltage at this point with respect to the ground. Similarly, when I talk about Vb, it is the voltage between this and the ground. The ground is here, so it's minus Vp secondary by 2. And Vp out, you know, it is nothing but a Vp secondary by 2 minus 0.7. So Va minus Vb is nothing but the voltage across the diode. It is nothing but the peak inverse voltage. So you can say the peak inverse voltage is nothing but Va is Vp secondary by 2 minus 0.7 minus, then Vb is minus of Vp secondary by 2. So this minus and minus become plus. So this become Vp secondary by 2 plus Vp secondary by 2 is Vp secondary minus 0.7. So this is the peak inverse voltage in the full wave rectifier. Okay, so this is the peak inverse voltage in. So you have to select the diode which is having a good capacity according to the Vp secondary, not Vp secondary by 2, it's according to the Vp secondary. Okay, so this is what is about the full wave rectifier. So we will see a problem. So this is the problem. So there is an input actually at the secondary terminal, and this is also given, that is Vp secondary. You have to find Vp secondary, and you have to find Vp secondary by 2. So you see here the question is a full wave rectifier is given, and the turns ratio is given as 20:2. Okay, this is the turns ratio. So and you have to find Vp primary, Vp secondary, you have to find the Vp out, you have to find the IL maximum, and you have to find peak inverse voltage. So first of all we will find the Vp primary. So what is Vp primary? It is nothing but V primary, the RMS voltage. Okay, you have to multiply it with square root of 2. So what is this? It is 120 is there, you have to multiply with square root of 2. So you have to multiply 120 with the square root of 2, it will be 169.7 volt. Okay, that's it. Now you have to find what is Vp secondary. What is Vp secondary? Vp secondary is Vp primary multiplied with number of turns in the secondary divided by number of turns in the primary, which is nothing but 169.7 multiplied with 2 by 20, which is nothing but 16.97 volt. Okay, next we have to find Vp out. What is Vp out? Vp out is Vp secondary by 2 minus 0.7. What is this? It is nothing but 16.97 divided by 2. So okay, 16.97 divided by 2 minus 0.7. okay, so this is equal to 8.4985 minus 0.7, so it will become 7.785. okay, next is the IL max. What is IL max? It is nothing but Vp out, you have to divide it with the RL, because you know the maximum voltage, this is the maximum output, so maximum output divided by RL. So it is nothing but 7.785 volt divided by 100, so it's become 0.07785 ampere. This is nothing but 77.85 milliampere. That's it. Next you have the peak inverse voltage. So just now I talk about the peak inverse voltage. It is Vp secondary minus 0.7. So Vp secondary minus 0.7. So this is nothing but Vp secondary is 16.97 minus 0.7. It's nothing but 16.27 volt. Okay, that's it. So this is the problem about the full wave rectifier. So next we will see another one which is nothing but the bridge rectifier. Okay, so we will see the bridge rectifier. So another kind of rectifier, full wave rectifier. So I have already told you the full wave rectifier has been classified into two types. So the first type was the one with the center tapped transformer, and the second one was the full wave rectifier, which is nothing but a bridge rectifier. Okay, so we will talk about the bridge rectifier. So the full wave rectifier has actually, with the center tap transformer, has only two diodes, but now we are going to see a bridge rectifier, and this rectifier is having four diodes. Actually it is made using four diodes. Okay, so what are these characteristics? You can see here it doesn't need a center tap transformer. It can be applied, you can use anywhere, if you, even though if you don't have a transformer, in some situation if you are working with a low voltage DC and all, or a high voltage DC also, you can use this. So it is having two diodes, one diode like this and one diode like this. Let's say this is D1 and this is D2. Okay, now I will connect here the ground point. Okay, next you see this is the two diodes here. Next I have another one, diode like this. This is diode like this. One is like this. Okay, and I will connect my load here. Load here. This is my load. Okay, and this is the ground point. So you can see whatever I have shown in the blue color, all are connected. Actually, this is the ground, because the grounds are connected. That's why. So this is the output V out. Now we will see this is the connection. Sorry, there is one more connection here. This connection is connected here. Okay, so you are giving the input between these 2 points. Okay, and you have 2 diodes. Now I will name these diodes. This is D1 and D2, and this diode is D3 and another one is D4. Okay, so we will see what will happen during the positive half cycle. Okay, we have a positive half cycle. We have a positive half cycle. During the positive half cycle, what is the polarity? It is positive here and this is negative. I told you, since this is positive, we will get here positive and here negative, and there is a turns ratio, number of primary turns and number of secondary turns. Okay, that we will discuss later. So you see here, this is negative and this is also negative. Now you see, this is p type, n type, and this is n type and p type. You see here the diode, the positive is connected, this is positive, and you are getting here negative. The positive is connected to the p, and this positive is connected to the n. That means your D1 is on and D3 is off. Okay, so when D1 is on, D3 is off. Similarly, we can talk about another thing. That means the negative is connected to the p type, and this is n type. This is p type and n type. The negative is connected to the p. That means the D4 is off, and the negative, the same negative is connected to the n here. That means this guy, actually it is on. So we can say that the D1 and D2 both are on, and you can say the D3 and D4 both are off. Actually, basically it is off. Now this is the situation during the positive half cycle. I can say positive half cycle. So what will happen? You have a voltage here, you have a voltage here. I can say you have a voltage here. This is positive half cycle. So you have a voltage here which is nothing but V primary. So the maximum is Vp primary. This is the maximum voltage. So you have a voltage here which is Vp secondary, which is the maximum voltage. So because of this, you have a current like this. The current will be moving through D1 because D1 is on, and the current will be moving like this, and it is going to the ground. Now you see, this is the negative terminal, so the current has to come to the negative terminal because the current starts from positive and it's go to the negative. So it is going from here, it is going to the negative terminal, but you see the D4 is off, so the current should take the path through the D2. So it is coming like this, coming like this. So the current is taking the path like this, and it is going to the negative terminal. So you can see the complete trace of the current during the positive half cycle. During the positive half cycle, this is the complete trace of the current. The current will start from the positive terminal, it will go through the D1, then it will go through the load resistance RL. After that, it goes to the ground, and from the ground the current will come through the diode D2 and it will go to the negative terminal and it will complete the circuit. Okay. Next we will see what is happening during the negative half cycle. During the negative half cycle, I told you this end is negative and this end is positive. Since this is negative, I will get a negative here. Since this is positive, I will get a positive here. Okay. During this negative, you can see this end become negative and this end become positive. So negative is connected to the p-type semiconductor of the diode D1. That means your D1 is now off. Similarly, you will get D2 as off, and also you will get D4 as on, you will also get D3 as on. That means you will get D1 and D2 as off, and your D3 and D4 as off. So this is the situation in the negative half cycle. Okay, so this is the situation. This is the situation in the negative half cycle. Okay, that means when the input is negative. So this is the first one was the situation during the positive half cycle, and the current was moving from top to the bottom. That means you are getting a positive voltage at the output. That means you are getting a positive voltage at the output. Now we will see what will happen during the negative half cycle. You can see here D1 and D2 is off and D3 and D4 is on. So what will happen now? So I will show with the same color that I have used. You see that this is positive here, I told you. So the current will start from the positive. The current will move like this. The current will take this path through the D4, and the current will move through the RL in the same direction. So since the current is moving from top to bottom, you can see has a positive and negative voltage. That means you are getting the same kind of voltage, the voltage with the same polarity. That means you are getting a positive half cycle again, and it's going to the ground. Now you see at the negative end it is negative. At this portion it is negative, so the current should come to the negative, but you know that D1 is off, so the current should come from D3 and it is coming from the ground. So this is the current direction. So this is the current direction in the bridge rectifier. So I will explain again the current direction. So you can see this is the current direction. Now we will explain again the current direction. So you have D1, D2, okay, then D3, and sorry, this is D3 and this is D4, okay, and this is the ground. It's connected here, and this is the polarity, this is the RL. Okay, so during the positive half cycle, I will say during the positive half cycle, okay, you can see, okay, I will use the red color. Positive half cycle, the positive and negative, the current will move through this D1 because D1 is on, this is on, so it will move like this. Then the current should come to the negative terminal, so the current will come from here because this is on, so it is coming from the ground. So this is the ground. Now you during the negative half cycle, so this was the situation during the positive half cycle. Since this is positive and this is negative, you are getting a positive voltage. So this is the positive half cycle. Then next, during the negative half cycle, you have a negative voltage, minus and plus. So this is minus and this is also, this is plus, and so this is plus. So you see here the current will start like this. It will move through the diode D4 because D4 is on now and D3 is on now. So this is, it will go through this. Next it will go through the load resistance. Okay. Now what is the situation? Now the current should reach the negative terminal. So it is coming from here and it is coming from the ground. Okay, it is coming from the ground. So this is the direction of the current, and you have to assume that these two grounds, this ground and this ground, both are short circuit actually, same point, short circuited. That is the meaning. Okay, short circuited. So the maximum, the input at the primary is Vp primary. Vp primary is the maximum input at primary. Okay, at the primary. And what is Vp secondary? That is the voltage between these 2 points. So Vp secondary, you have the number of turns in the primary, these two number of turns in the secondary. So Vp secondary is nothing but Vp primary multiplied with number of turns in the secondary divided by number of turns in the primary. Okay. Now you see here what will be the maximum output. I told you during the negative half cycle also you are getting the same current direction, that is positive and negative, so you are getting the positive cycle again. So what is the maximum output? That means Vp. P means peak or maximum. Okay, P means peak, Vp out. Okay, so what is Vp out? Vp out, Vp out. What is Vp out? You have the maximum input at this end, that means its Vp secondary is the maximum input, and you have two diodes. One diode is here and another diode is here. During the positive half cycle there are two diodes which is on at a time. Since one diode consume actually the voltage drop across one diode is 0.7, since there are two diodes on, so these diodes will take a voltage of 1.4 because 0.7 multiplied with 2, because there are two diodes. So Vp secondary minus 1.4 will be the output, because this diode will consume a voltage of 1.4, so this will be Vp out. What will be the maximum current? IL max. Maximum current is nothing but, what will be the maximum current? The maximum current is maximum voltage Vp out divided by RL. Okay, that's it. Now we will talk about what is the peak inverse voltage. So I will talk about it in the next page. So we have the rectifier. Okay, we have the rectifier, and I told you this is diode D1 and D2, and this is diode D3, and this is diode D4 or D3, and this is D4. Okay, now this is ground and this is the point. Now this is RL, and you are taking the output here, V out. So whenever we will take the positive half cycle, any of the half cycle you can take, positive half cycle, I told you during the positive half cycle D1 and D2 are on, and the next point D3 and D4 is off. So to find the peak inverse voltage, we consider diodes which are in off state. Okay, which are in off state. So you can take any of this D3 or D4. Okay, now I will take any of the diode. Let's say I consider D4. For example, I can consider D4. So what is the voltage across D4? So we will see this diode. So I will take VA here and I will take here VB, because D4 is off. So the voltage across the D4 is nothing but our peak inverse voltage, which is nothing but VA minus VB. Okay, what is VA? That is the main issue. What is VA? VA is nothing but, it is connected here, you can see it is connected to this point, and this point is nothing but V out, and the maximum at this point is Vp out. So VA at the maximum value is nothing but Vp out. What is Vp out? Vp secondary minus 1.4, that you know, because we have already derived this equation. Vp secondary minus 1.4 is Vp out. Now what is Vb? What is Vb? Vb at the maximum value, what is its maximum value? What is the maximum value of Vb? You see here, this is Vb with respect to the ground. As you told here, this voltage is plus because D2 is on, so 0.7, and you consider Vb at this point, and at this point it is minus sign, and the voltage with respect to the ground is just 0.7, so minus 0.7. So this is how to calculate. Now we will find the peak inverse voltage of the across the voltage D4 anyway, or the peak inverse voltage of the system, it's nothing but VA minus VB. It is VP secondary minus 1.4 minus 0.7. So this is nothing but VP secondary minus 0.7. So this is the voltage across the peak inverse voltage. Okay. So the peak inverse voltage of the diode, okay, the peak inverse voltage of the bridge rectifier is Vp secondary minus 0.7. Okay. So that's about the rectifier, full wave bridge rectifier. Okay. So we have one more topic basically, which is known as the filtering technique. So with after the completion of the filtering technique, we will do a problem on the bridge rectifier. Okay.